Suppose we have this piecewise function and you're asked to evaluate this one-sided limit. What do? Well, first of all, when you look at this one-sided limit, x is taken to -1, and minus means it's approaching from the left, which means your x value is less than -1. Now that's important for us because when you deal with a piecewise function, you have multiple definitions of the function, and they are only valid under certain contexts, okay? Depending on what x satisfies. Well, since x is less than -1, and it says if x is less than -1, you should use 1 minus 2x as your function definition, you should switch out the f of x by 1 minus 2x. Now, once you have fx replaced by 1 minus 2x, then it's really easy to evaluate this limit because all you have to do is plug in this -1 here. Now, when you plug in, you could put -1 minus, but it really doesn't do much here because all you need to know is what value does the function get closer and closer to. So as x gets closer and closer to -1, we know that 1 minus 2 minus 1, when you multiply negative by negative, it's positive, so it's 1 plus 2, and you get 3. And it's the value of 3 that f of x gets closer and closer to. Now, if you're really curious to know what this minus would mean, it means that since it's slightly less than -1, actually this will be bigger than 2, so the limit would be 2 plus, so the final limit would be 3 plus. Now, such a calculation might be important when you have something that gets close to 0, or when you have something like x plus 1 and you have some x squared, and if you're sending x going to -1 minus, this small detail of whether this goes to 0 minus or 0 plus controls the fact whether this should be going to positive infinity or negative infinity. But in our case, it really doesn't matter. All we need to know is that limit gets closer and closer to 3 as x is taken to -1 minus. Now, if you're still puzzled why you get 2 plus, all you have to do is just think about an example of -1 minus. -1 minus is -1.0001. This is slightly less than -1, right? If you plug that in, you're going to see that this value is like 2.0002. Yeah, 0.2, and then therefore it's slightly bigger than 2. That's how it works. Okay, so that was all unnecessary. So if you didn't understand, don't worry about it. All we're trying to find out is the limit as x gets to -1 minus, and that should be 3. Okay, so what? That's the answer to the first one. The second one is asking for the value of this a. What should this value be when, if the limit as x goes to -1 of f of x does exist? Now you have to decipher what this means. What does it mean for the limit to exist? Well, we say that the limit exists if the left limit exists and the right limit exists, and if they have the same value. Okay. Now we already have the left limit. This is our left limit as x goes to -1, and that's 3, right? So we know that this is already 3. So now let's try to see what the right limit is. Right limit would be the same thing, limit x goes to -1, but this time you're approaching to -1 from the positive side, so we're going to write -1 plus of f of x And in our case, this means x is slightly bigger than negative 1. So in this would fall into this context, right? If your x is like slightly bigger than negative 1, so think about examples like negative 0.9, that's slightly bigger than negative 1. If x is like negative 0.9, then negative 0.9 is certainly bigger or equal to negative 1. So this is satisfied, so we're going to use this, okay? So we use limit x goes to negative 1 plus of the second formula, x times x plus a. And that means now you can plug in negative 1. Notice that this plus, or whether it's a minus, really didn't do much when we evaluate the value. It was crucial when we were determining whether we should use the first formula or the second formula. Alright, so we plug in negative 1, so it's negative 1 times negative 1 plus a, and it's really important to put these parentheses around. That kind of helps you out with the negative signs. A lot of times sign mistakes are made because people forget the parentheses, okay? So let's see, if I have negative 1 plus a, I can multiply this to inside negative 1 times negative 1 is positive 1, negative 1 times a is negative a, so that's your right limit. Now you might be a little nervous because the final answer has an a in there, but that's fine. And now we write down our condition. The condition for the function limit to exist is that the left limit, which is 3, and the right limit, which is 1 minus a, they have to be equal. Well, for that to be equal, I can first add a both sides, and you get 3 plus a equals to 1, and then subtract 3 both sides, so you get a equals to negative 2. Okay, so that's the answer. All right. So we have 3 for the first answer, and the second answer is a should be negative 2. Okay, now if a is the value found in part B, in other words, if a is negative 2, what is the value of f of negative 1? Well, this is just a pre-calculus question. What is f of negative 1? Well, that's like, since negative 1 is greater or equal to negative 1, we have to use this formula. So this formula should be used. And so we first take this formula, and then we should plug in x equals to negative 1. Okay, so this bar with vertical line with x equal to something means whatever this formula is, you plug in this value. It's a very handy notation. Okay, so you have this, and you plug in negative 1, you get negative 1 times negative 1 plus a. Oh, but a is negative 2, right? So that's negative 1 times negative 1 plus negative 2. Negative 1 plus negative 2 is negative 3 times negative 1, so that must be positive 3. And that's the answer to part C.